Welcome everyone to the Lecture 7 of Basic Foundation Physics Lecture Series. The topics that we are going to cover in this lecture are momentum, impulse, and law of conservation of linear momentum. Let us start with the definition of momentum. So, mass of a body is m and velocity of this body is v. Then momentum of this body is equal to product of its mass and velocity. So we know that this particle is mass of body into its velocity v. Since velocity is a vector quantity and we are multiplying it by a scalar quantity, so momentum is also a vector quantity. So momentum is a vector quantity, and SI unit of momentum is SI unit of mass is kg and SI unit of velocity is meter per second. So SI unit of momentum is kg meter per second. And most importantly, direction of momentum is in the direction of velocity. Next up we have the concept of impulse. So from Newton's second law of motion, we can say that F is equal to delta P by delta T, which is nothing but the force is equal to rate of change in momentum of the object. So from this expression we can write delta P is equal to F into delta T, and this expression is nothing but impulse, which is denoted by vector J or vector I. So impulse is nothing but change in momentum or force into time, and it is also a vector quantity. And direction of impulse is in the direction of change in momentum and SI unit of impulse is same as the SI unit of change in momentum, which is kg meter per second. Or from this expression we can write SI unit of impulse as Newton into second, because SI unit of force is Newton and SI unit of change in time is second. So SI unit of impulse is kg meter per second or Newton into second. Next topic is the law of conservation of linear momentum, which is a very important topic for us. What does it say? According to this law, if summation of external force applied on a system of particles is equal to 0, then initial momentum of system is equal to final momentum of the system. From Newton's second law, we can say that if we apply external force on system of particles, then it will be equal to rate of change in momentum of the system, and if this summation of external force applied on the system is 0. So delta P by delta T will be equal to 0, and from this we can write that delta P will be equal to 0. So change in momentum of a system is equal to 0 when external force applied on the system is 0. And we know that change in momentum is nothing but final momentum of the system minus initial of the system, and this is equal to 0. So from this we can conclude that P final of system is equal to P initial of the system. This is nothing but the final momentum of the system is equal to initial momentum of the system when summation of external force applied on the system is 0. So from this we can say that total momentum of a system of particles will remain conserved when summation of external force acting on the system is equal to 0. So this is the law of conservation of linear momentum, which can be applied on any system if the vector sum of external forces acting on the system is equal to 0. Let's take an example to understand the law of conservation of linear momentum more clearly. So in this example, a bullet of mass m is moving with the speed v. This block of mass capital M is initially at rest, and this bullet gets embedded into this block, and after some time they both move with a common velocity v prime, and we have to find the expression of common velocity of this block and bullet. So let us first discuss if we can apply the law of conservation of linear momentum on this system or not. So when this bullet strikes this block, so this block will exert a normal force, an impulsive normal force on this bullet, and in its reaction this bullet will also exert an impulsive normal on this block. So if we take the bullet as a system, so an external force is being applied on this bullet, so we cannot apply law of conservation of linear momentum for this bullet. Similarly, on this block, an external force is being applied by the bullet, so we cannot apply law of conservation of momentum for this block, but for this entire system, these forces are internal forces and they will cancel each other. So we can apply law of conservation of linear momentum for this system of bullet and block. So if we have to write the initial momentum of the system, so it will be equal to momentum of bullet plus momentum of this block, and momentum of this bullet is mass of bullet into velocity of this bullet, and magnitude of velocity is v, and it is directed in this direction, plus mass of this block is capital M, and since it is at rest, so velocity of this block is equal to 0. So initial momentum of this system is m into v in this direction, and final momentum of this system will be equal to mass of bullet into velocity of bullet plus mass of block into velocity of this block. Since both of them are moving with common velocity v prime, so final momentum of this system will be equal to mass of bullet plus mass of block into their common velocity. And since the summation of external force acting on the system of bullet and block is equal to 0, so we can say that initial momentum of this system will be equal to final momentum of the system, and initial momentum of the system is equal to mass of bullet into initial velocity of bullet, and final momentum of this system is equal to mass of bullet plus mass of block into common velocity. And from this equation we can say that final velocity of the system will be equal to small m into v upon small m plus capital N. So this is the expression of their common velocity. In the next example, a gun is initially at rest and it fires a bullet of mass m whose speed is v with respect to ground, and the gun recoils with some speed, and we have to find the magnitude of the recoil velocity of the gun. So the gun must be exerting some force on this bullet, because of which it will start moving, and in its reaction this bullet will also exert a force whose magnitude will be same as this force, but the direction of the reaction force will be opposite to this force. But this force will these two forces will be internal forces for this system, so for this system also summation of external force is equal to 0, so we can apply conservation of linear momentum for this system. So since external forces summation of external forces is equal to 0, so initial momentum of system will be equal to final momentum of the system. So in the initial situation both bullet and the gun are at rest, so initial momentum of bullet is mass into its speed, which is equal to 0, and final momentum of and initial momentum of this gun is equal to mass of gun into its speed, which is also equal to 0. So initial momentum of the system is equal to 0, and final momentum of this bullet is mass of bullet into its speed, which is in this direction, and final momentum of this gun is equal to mass of gun into velocity of gun, but we have assumed that this velocity is in the opposite direction of the velocity of bullet. So initial momentum of the gun is equal to 0, and final momentum is momentum of bullet plus momentum of the gun. And if we assume any direction to be positive, let's say this direction is positive, so from this we can say that this will be equal to plus mv, and momentum of gun will be equal to minus n into velocity of the gun. From this we can write recoil speed of gun is equal to m into v by capital N, And since this expression is with positive sign, so we can say that the direction of the bullet that we had assumed earlier in this question is correct. So if a gun fires a bullet in this direction, so it will recoil in the direction opposite to the direction of this bullet. I hope this video was helpful. Thank you so much.